Okay, hi everybody. We're back. Sorry about that delay. It was or that dying event. It was apparently the event just ended, and we couldn't get it started again. So I had to create a whole new one. I put it in the link to this event in the old event. So hopefully you guys are migrating over as we do this. This is twice this technology has sort of messed up on me. So hopefully that won't happen again because we've got another one coming up on Friday. So we don't have we run out of a lot of time. I don't think anything we said before got posted. I think it's been dead from the so. And here's Stephanie. Great, we're back where we started. So everybody, my name is Tony Darnell, and I'm the social media manager for Space Telescope Science Institute. And we have been at the mercy of a lot of technical difficulties today, but we want to give you an update on a citizen science project that we have been working on starting in early January, which was called Stardate M83. It was a project that was designed for the Zooniverse Citizen Science Initiative. They have a whole family of these things, and this was one of them. And it was designed by all of the people that we have here with me. I won't spend a whole lot of time in introductions. We'll just talk about who they are as we go. Hopefully you guys can still interact with us via the event page and Twitter and using the Hubble Hangouts tag and everything else. So, Brad, why don't you? The M83 Citizen Science Initiative is kind of wound down, and we're going to go ahead and assume that people have seen the previous Hangout. If you haven't seen the Hangout on what this is about, to kind of give you an introduction into what this is we're talking about, I would encourage you to watch our last Hangout topic, which is on our YouTube channel and on Google+. That'll give you some background. Today, what we'd like to talk about, though, is how it went. The website is still up. But it is no longer, they're no longer taking the data that are coming off of it, and now everybody's just kind of sifting through the results. So Brad Whitmore, you are one of the leads astronomers that was working on this issue. You're an astronomer at Space Telescope Science Institute. Tell us a little bit about what you've learned from this whole experience. What were some of the surprises that you found from the initiative?
I think the biggest surprise is that these citizen sciences are really good. I thought
oh, that's no surprise. Come on.
I thought that they'd be kind of overwhelmed by some of the complexity and stuff, and they just, like troopers just kind of got in there, asked a few questions, and away they went. I'm going to kind of just real quickly show some results just to show that the basic idea.
Let's jump right to the punchline. Let's go ahead.
Yeah. Okay. So let me screen share here.
Yep.
There we go. Okay. Now let's see, which of these do I hit? I guess let me try that one.
It's the red. It's the little green button.
The little green button. Yeah, that green button.
There you go.
Okay, how's that?
Got it. We see.
Okay. So there is M83, the galaxy, and these are examples of some star clusters. And the whole idea is whether the citizen scientists can measure the ages. And so to test whether that was happening, I'm going to go to a discuss feature. Now this was the fun thing about it, that besides just using the tool, once people had measured things, they could go to this social medium and show some of their favorite images and stuff, and have little discussions in discussion boards. Here we had some of the more frequently used discussion boards. And let me look for the one that says, let's see, some early results, some quick results. So I just put these in about a week ago just to show how well the citizen science.
This is the built-in forum that sort of not comes with it, but it's something you can develop with your initiative.
Right. Okay. And so here are some quick results based on, and this is about half of the data. And so what we're going to plot here is the age estimates from the citizen scientists. So here we go, citizen science age category. So 1 would be an extremely young cluster. And there's each of these little data points is 20 different measurements by citizen scientists of a particular cluster. So in this case, the fact all
wait. Citizen science age category.
Right. And so in this case,
is what they found as the age of a cluster.
Right.
The general public.
So for a particular cluster, say this one right here, this means that 20 different people all said it was extreme. It was very young. It was category 1. Okay. And then this one might be that 18 people said it was very young, and 2 people said that it was category 2. So this is something that citizen scientists on this axis thought were extremely young, and then near the top, let me go ahead and, oops, there we go, a little smaller. Okay, there we go. And near the top, this is the one that the citizen scientists said, these objects were extremely old. And how did this correlate with our own estimate? So on the bottom axis here is what we've been using for the ages for these different clusters. It's based on, and discussion in the About the Science, the spectral energy distribution fitting, and it's in logs. So it's not in kind of people terms; it's more astronomer terms. But this is 6. This just means 10 to the 6, or a million-year-old cluster. So we think this is a million-year-old cluster, and this is a billion-year-old cluster, 10 to the 9th. And so our estimate would be, based on the way we usually do the ages, is this should be a young cluster and this should be an old cluster. And you can see, we agreed that the citizens said these were young, we said they were young. Up here at this top end, they got these as old clusters, we got them as old clusters, and so it agreed quite well. Now the fun part comes to when we average all these together. We take the fact that not just 1 or 2 of us are measuring it, but we average them all together. And so here's the kind of, if you will, the final coup de grace. And now it's an extremely strong correlation that their measurements when they're young and ours are in very, very good agreement. So this shows that it works very well. The kind of interesting aspect, if I go back... So this is a
plot that compares what they found versus what you guys expected to find, and you found that, or what you estimated, and that you found there was a really close correlation to this.
Yeah, extremely strong, and it's, statistically the scatter is really small.
So this is telling you got some pretty good science out of it.
Exactly. Yeah.
Okay.
Yeah. And maybe just to jump to kind of let's see, back to here. If I look here and I go to what's called some of the outlier things. So let's consider some of these data points here. In this case, the citizen science said, yeah, they're young. They're really very young. Our program said that they're old. So who was right? Citizens were right, or were we right? And the answer, the quick answer, and I'll show you in a picture, the answer is the citizens are right. And this is the whole reason for doing the project, that we can use their estimates here to fix up our age estimates. Now, there's not a whole lot of them. There's like 2 or 3 or 4 or 5% that are big outliers here and up here. But the bottom line is that we're going to improve the science.
Okay, so slow down, Brad. You're going really fast. So what you're telling, go back to that plot. What?
Okay. Okay.
So you're going really fast, and I know you probably have a lot to show. But so this is an example. This plot in the lower right of all of these data points you're saying is where the citizen science helped improve what astronomers were doing, right?
Absolutely, yeah.
Okay, now what about this mass in the upper right? What's all that? I'm seeing an awful lot of dots up there. Is that anything?
Well, it's the same. This just shows the overall correlation. So up here, citizens said that these clusters...
Okay, that's where there are areas of agreement. Okay, I just want to clear this up.
That's the agreement. And
okay,
the outliers are down here, and I'm going to show you the image in a second.
Yeah, because this is complicated what you're showing. I want to make sure people understand it. So,
right.
Okay.
But if I go to the next picture, it should clarify it. So let's just concentrate on these.
Okay.
Brad's like going, whoa!
I know. Okay. So the question is why? Who got it wrong and why?
Right. Okay. So citizens
the algorithm or the citizens?
Okay. Citizens say it's extremely young. Our program says it's old. Why? Okay. So let me go and show a picture. Since okay, let's see right here. Here are 3 of those objects that were what I call outliers. Okay. This is just a picture. This is a program that we use to identify where things are, etc. But the right is a nice color image. So this is what they used when they actually looked at the cluster. So so right off the bat, so here are the ones, and the citizen said that all 3 of these are young. So that one is kind of right here. 1637 is right here, and right here is the last one. Okay. The bottom, the simple thing is that you look here, these are all extremely young. These, if you go through the exercise, they have a lot of pink hydrogen gas around them. And so everything in this region is extremely young. Citizens are exactly right. And the question is, why did our program not get it right? And the bottom line is that in most cases it's blowing out the hydrogen gas. Say we measure the color of that object right there. we don't realize that there's all this hydrogen gas outside of it, which the citizen can see very easily, but our program doesn't know about. So that's the value added that they had. They looked at it and they said, okay, is there anything around here that shows that it's actually got a lot of young hydrogen gas around it? And the answer is yes. So the bottom line is citizens got it right, our program got it wrong. We'll be improving about 3, 4, 5% of our ages just in that part of the diagram, but overall we're going to be improving in a similar way because we've got such good statistics.
Great, that's wonderful news. So it's been very successful. You were getting hopefully just what you had hoped for from the human ability to be able to detect patterns and stuff. Bill, do you have any comments on that?
So I wanted to comment on that previous plot that Brad was showing. You asked about the upper right and why were there so many points up there, Tony. And I think what the citizen scientists have found out, and we expected actually, is that there are a lot more old clusters, and so there's a lot more points in the upper right than there are points in the lower left. There's just a lot of older clusters and relatively few young ones, and so that's coming out of this plot as well.
Oh, okay, that's good. Thanks for clarifying. What about you, Carol? Do you have any comments on these results?
I think it's fantastic. It means that the astronomers actually, we have to go back to the classic visual inspection of our data, which is number one. And number two, Bill's point that there are so many of the old clusters, you wouldn't really expect that looking at M83. It's got this beautiful structure, lots of blue and red stuff, and you think, oh man, lots of star formation. Well, it turns out it's got a lot of old clusters that have been hanging around for a really long time. So that's very interesting from the standpoint of how this galaxy formed. It formed a lot of old clusters that we wouldn't necessarily have known about unless we had done this. So I think that's pretty darn interesting.
Yeah, same here. So, Brad, what else you want to highlight here? You got other things you want to show?
Yeah, just one more thing here, and again, and I was just kind of amazed at how good the citizens are here. This is part of the explore part of the exercise, and so we invited them to go ahead after they work on the particular cluster to go around and say, oh, I think this is a background galaxy, I think this is a so-and-so. And so here's an example where 4 or 5 citizens thought that this thing here was a background galaxy, and these also. So here's the color image here. So that one, they said, and this one, those are pretty easy. The one that I didn't realize is, okay, down here, they think there's something down there.
Oh, and that little red smudge there. Yeah, I see
right
that.
on the edge of this cluster. These guys have extremely sharp eyes and really spent some time looking around. And while they were getting these 3, well, these 2 are definitely background galaxies. This, I can't be positive, but it's a very good candidate. And at the same time, they didn't mark a lot of other stuff. I mean, this is a star. You can see it's much more concentrated. They didn't mention the clusters. So I was really quite amazed at how clean their exploring showed things up, too. So this is an example of background galaxies. They did a bunch of other things, too, looking for supernova remnants, looking for well, other artifacts that we, to make sure that they're not clusters, etc. But anyway, this is just one example that came out of the Explore.
Yeah, so I'm happy to see that we're getting our viewers back, guys. Again, I'm sorry about the difficulties earlier, but another thing about the point you just raised, Brad, about that galaxy that's kind of really close to that foreground star. One of the automated programs that's used to sort of de-blend those things has a very hard time with things like that. So that's where you're having people look at these things, do it much better than a computer program can do it in a great many instances. So. Are there any other highlights in particular you'd like to point out about the project specifically, either Brad or Carol or Bill? Because I have a go ahead.
Well, I was just going to say that I think that the classification was very useful, but I think it just wouldn't have been the same without the discuss area. The discuss area was really important for us to interact with people, but also for the volunteers who were looking at the data to interact with each other.
So they could ask questions and things like that?
Yeah, and they'd answer each other's questions and they'd interact that way too. And so that was very useful to see all that dialogue, because it made us think a lot about what the data looked like and what this galaxy is about.
Okay, yeah. So what are you showing now, Brad? Anything?
No, it's just that this is the discuss part, and this is just this is just a great deal of fun. I mean, things would come up, you'd click on it, and you could make a few comments or something. They'd write in there lots of clusters close together. Someone would come and make a comment here. They'd say, you know, I think I see a ring of stars around there. What's that mean? I'd write a little thing. People would find some more. The social aspect of it was really quite amazing. They would keep little collections, you know, things that have rings of stars, artifacts, bubbles, etc.
So this project sort of highlights to me one of the things that I think is going to help solve a big problem in astronomy going forward, and that astronomers themselves don't have time to physically sit down and look at every single image that's taken through all the telescopes in the world. There's just too much data, and it's going to get even worse. And as Carol said, you know, this particular project highlights the importance of being able to actually look at your images. So I wanted to ask you guys, what is your feeling for, is this a critical component, do you think, in the future of astronomy, to be able to look at big data, to understand the big data, the torrential flood of images that come out of these telescopes? Is this a possible avenue to help solve some of these problems? Because you can't automate everything. In fact, we're only as good as our algorithms. But is that really true? I mean, does this help us become better astronomers?
Yeah, I have a comment there. Basically, you have to find your niche, and for certain projects, and we think we found one here, this technique works very effectively and helps us out a lot. It doesn't mean it's a universal panacea for every project, but for certain projects that are where you craft the goals of the project properly, the citizen science way of doing science is very effective and very useful to the astronomers. So just an example of that, I would just say, you know, Brad showed you a couple of very quick look results from this stuff, but for instance, we've got the size measurements of the clusters that people did, we've got the colors that they indicated of the clusters, all that information we've barely scratched the surface on looking at this point, and so as we go forward, hopefully we'll get a lot more than those quick look results that Brad was showing out of the work that the citizen scientists put into this project.
Okay, I want to get Stephanie in on this just a little bit now, this discussion, because she was the lead graphic designer on this, but she was also instrumental in designing how the flow of the website, how you interacted with this Stardate M83 project was directly related to her work. And so, Stephanie, I want to ask you, and this is mostly for people who might be interested in, say, starting a Zooniverse project of their own. What was your life starting with this project, and was it easy to plug in? Were there any special challenges? Did you learn anything that was like surprising as you set this thing up?
Well, this was the first Zooniverse project that any of us had worked on, and it actually was one of the first projects that Zooniverse was working on with somebody who wasn't part of their own staff. So it was a bit of an experiment all the way around as far as that goes. But really, what it comes down to are the types of things you need to know when you're designing any kind of app or website. You need to know exactly who your audience is, which fortunately the Zooniverse audience is, you can make some assumptions about how much they know, but you can't make entirely assumptions that they know everything an astronomer would. I mean, they are very interested, and a lot of them do have astronomy training, but you have to kind of take a step back, which is part of my role, is being the person who's not an astronomer in the room. How would I understand this problem? So Brad and Bill and the rest of their team had identified these criteria that they are looking for when they look at an image, and part of my job was to help them break that down into what would a person who doesn't understand astronomy know. You know, you can't really say, like, look at the H alpha region and just leave it at that. You have to kind of describe and explain what that is, and we went through time and again about how to do that in a way that is acceptable and not introducing any misconceptions or oversimplifying.
Or biases too, I could imagine would be a problem.
So, for example, we ended up going with simplifying the colors, kind of really honing in on the color information, or as you see on the screen that you have up right now, you know, is there a cloud? Is there a pink cloud, or isn't there a pink cloud? Keeping things very concrete and visual. They knew exactly what criteria they wanted people to be looking at, but the first step we had to do in developing the web app was figuring out how we can communicate to other people what it is they're trying to answer, and presenting that information in a way that makes a logical sense to go from one to another. For example, if there is a pink cloud, you have a couple of additional steps, because that pink cloud tells us a lot of things about the object. That's the very young stars would have that. And you wouldn't need to ask those questions about any of the objects that don't have those items. So let me just really quickly share on my desktop an example of the document.
Okay.
This is the digital version. I assure you the ones we actually used were very marked up. At the end of every meeting, I would have.
Oh yeah, that's been cleaned up for publication.
Yeah, this is the before the meeting version. After the meeting, I would have notes scribbled all over the place, and I don't know how much you can actually read here, but there was a lot of placeholder things like the beautiful image of the galaxy goes here, because this was the conceptual phase. This is figuring out, okay, how do we get everybody to get from point A to point B? And there were lots of iterations of this as we went back and forth and tried to have different features or different workflows. Ultimately, we tried to keep things as simple as possible and as few options for people as possible. So there was just a very relatively, I don't even think this is the really final version of it. Actually, now that I'm looking at it. And you can see there's all these decision tree points, and it's basically a glorified flowchart, but it was a really important tool to really narrow down what the app itself does that will enable the science to happen.
I wanted to make a comment about the flow, is that I had to be reminding everybody that it was nice to have the flow, which is kind of an analog thing, but in each case, the scientists have to understand when it gets codified what number is going to come out of that, and how is that number going to be different if somebody has done a different activity. You know, they've clicked on this instead of that, they've decided to do this instead of that. So the interface is one thing, but there's all the programming behind it where everything the user does ends up as a number. And so now we have those numbers, and that's what we have to analyze.
Yeah, that's what. So one of the things I'm really struck by looking at this is how much the science is driving the design. I mean, you simply can't, do a plug and play kind of thing. You have to start with your science questions, and then I remind everybody, wait a minute, if they click here, this has a science reason for it, and we've got to understand what that means. So that's not. It's a non-trivial thing. How much did that make your life miserable, Stephanie?
Let's just say it was an iterative process.
Yeah, I can imagine.
Because that is, as I work with a lot of scientists, a big part of my job here at Space Telescope Science Institute is creating products that are communicating science to the general public or to specific audiences. And there's always a balancing act between having enough science information and not overwhelming people, which is very easy to do, especially when you're in your zone, and especially when you're excited about your project. Like Brad is very excited about his research and gets in the zone, and it's a little bit tricky sometimes to remember to take a step back and remember the person who has no idea what they're looking at when they look at this picture, but they want to know.
Oh, I just had an experience with that right there. When he was showing us that graph, I had to slow him down. He was so excited.
We're trying to get to the punchline.
I know you were quick on this. So,
and the other thing that I wanted to say is that we and Zooniverse tested this before we let it go. So we had a number of people who actually tested the interfaces, and it's always wise to do that because once the whole group gets in the zone, then we don't hear anything else. So then we need to show it to external people and say, okay, this is what we think, and they're like, no, that's not what you're doing. So that's an important step as well.
Yeah,
we actually did a few rounds of user testing. We did some inside our very own building where we found a lot of things immediately as soon as we started showing it to other people. And then the larger Zooniverse community also helped us refine it from there. And that's another part of the iteration that is necessary. And also a recognition that when you're making a project like this, you're making an application that people want to use, a tool for people to use. You want it to be easy. You want it to be a little fun, maybe, and intuitive, and not confusing or frustrating. And that takes a lot of. You have to actually put a thing like that in front of other people, and let them play with it, and let them tell you when they get confused, when they're overwhelmed, when they needed more explanation than we were providing, or when we weren't explaining things clearly enough. And all those things came out in user testing. If any of the folks listening in on this were in the beta test group with the Zooniverse team, thank you very much for your feedback, because it was very helpful.
So I have a question I'd like to ask all of you, and this was coming up as you guys were talking, and I'll be who wants to comment on it. But so you've got an engine called Zooniverse that's basically is about as modular as something like this could possibly be for doing asking science questions that can be crowdsourced. But I can easily see that someone could design a website like this and be pretty happy with the buttons that are getting clicked and getting some results back. But what about what Carol said, which was, you have to fully understand what the interactions are? Is there a danger of an unintentional bias being introduced into any of these button clicks, just by virtue of the design or the way you guys laid it out? Do you, as opposed to, say, an automatic program who gets it wrong, is that, it may or may not get the answer right, but what about that? Unintended biases. Do you think there's a danger in those being introduced in a citizen science project?
I think there can be, and there's also. I have been involved in several Zooniverse projects, and it's always a surprise what the citizens will do with the interface, and it's like, oh, we didn't expect them to do that. So sometimes you can't think of all the scenarios, and that sometimes uncovers the biases that you're talking about. Oh, we mean this, and they are interpreting it that way. So, yeah, and that's why the testing and also monitoring it the whole time so that you know ahead of time, oh, you know what, we biased the results, but we're not going to change anything. We just have to remember that when we're analyzing the data. So that can happen for sure.
Along the same lines as people are talking about, as far as a bias, the fact that there are other Zooniverse projects, and so we've got a trained set of people in many cases that are very good at galaxy classification, say, and so they're seeing galaxies in cases where I'm seeing a star cluster or something. And or some people, there's a Zooniverse project to look for gravitational lenses. And so they're seeing, oh, doesn't that look kind of like a gravitational lens? While we think, oh, no, it's just kind of random stars. You get 100,000 stars. Sometimes they're going to line up and make a little, like, Einstein cross type thing. Now, those particular, quote, biases, I don't think would affect, our age dating type thing. But it was interesting to see that, yeah, there was an interested audience that had certain preconceptions or training, if you will, is maybe the thing I'm trying to say.
Okay. Well, I'm gonna go a little bit later than we planned because we had some problems here, because I want to ask you guys about papers. What kind of papers can we expect to come out of this? And are you guys? I know you're still digesting the data. You're still looking at the results of this. But what kind of when do you anticipate papers coming out of this? And will the people that were involved get any kind of authorship credit?
Yeah, along those lines, we've kind of identified 10 of them had
Hey,
multiple.
Brad, can you unshare your screen for just because I'm.
We want to see your face.
Yeah, I'll keep
okay,
looking at
that's
that.
right. I got to keep remembering. There we go.
Yeah.
Okay.
Okay.
Go ahead.
I like the other stuff better.
You know what? Second thought. Go back.
So we have identified the kind of 10 top users. Some of them had thousands, tens of, not quite tens of thousands. I don't know if we got anyone over 10,000, but thousands of classifications. And so we'll add them in an acknowledgement at the bottom, and I'll keep them abreast of the results, etc. And so that certainly was a kind of a fun aspect. As far as when the papers will come out, papers take a few months to put together, and then you have to get them refereed, etc. So the papers themselves will probably take about 6 months. Are we still on, or?
Yeah. Keep going.
Okay.
Someone just joined. I'm not quite sure who.
Etc. So the first paper, a very specific paper, will be on cluster selection and age dating, and it'll actually feature a lot of the citizen science stuff, how we used it to improve our age estimates, check our cluster selection, etc. So the first paper, and I kind of drafted it already, will actually use a lot of the citizen science results.
Good. Well, that's. It got a time frame, or is it just too early?
I mean, we'll have a draft in a few months. It probably wouldn't show up all the way in the literature for 6 to 9 months is the kind of a normal cycle of getting papers all the way through the process.
Well,
They'll probably do presentations at like the American Astronomical Society.
Good point. Yep.
Good. Okay, great. And I'll make sure to keep people posted too on our social media channels because you guys need, you guys participated, and so I'll as soon as the paper comes out, Brad's going to let me know, and we'll get the word out there. So let's see. I wanted to. Comments here. Tanks in space is going. Lately, it's beginning to look like star clusters were already present 80 to 100. Is that 100,000 years after the Big Bang? Does your data confirm that too?
Yeah. Well, we wouldn't go with this data set. We wouldn't be going. Let's see. Maybe I shouldn't answer it the way. So old globular clusters, which we can see in the Milky Way, etc. They did form very, very early. So the fact that we've got some old globular clusters in M83 does, pretty much fit into the standard picture that a lot of the clusters did form very early. But the newer thing is that a lot of them are still forming, and that's kind of the focus of the the young star-forming galaxies like M83 is the young clusters are still forming. But there's plenty of evidence that star clusters were forming, not too long after the Big Bang.
Yeah. How old is M83, by the way? Is it a pretty young galaxy, old galaxy? How old is it? Well,
it's a little hard to put an age on. I mean, it started to form, hundreds of thousands of years after the Big Bang, but it's still forming. I mean, there's still gas falling into it. There's still stars forming, etc. So it doesn't really make sense to just say, oh, its age is so and so.
Okay. So Burnham on the event page made a great comment. Until quantum computing is perfected, there will always be a place for citizen science. There's just too much data for astronomers' computers to handle. And I got to tell you, that's something that's a lot of people are talking about now. Of course, they use the catchphrase big data, but nobody really knows what that means in any particular context. But it is simply true that when, even the Hubble Space Telescope takes more data than any one person can look at individually. So what do? I mean, when you're trying to do science. Astronomy used to be a really boring, painstaking thing. Remember Clyde Tombaugh looking at using a blink comparator to try to find Pluto? I mean, no, who does that now?
I think that's really amusing. Maybe it's because I'm one of the older people here, but a lot.
Well, you actually do remember.
Oh yeah, I took photographic plates in a telescope, and I actually looked at star clusters on photographic plates. But remember, all of these algorithms came out of people looking at clusters and stars and galaxies and then trying to make a computer algorithm to reproduce what they did in their head. Yep. And so that's why I'm not so sure that citizen science and the broad cognitive ability of humans is going to be superseded by quantum computing or anything else. I think we will always be pushing algorithms and learning new things. The thing is to get the algorithms to get us to a point where we can discover something new rather than just keep doing the old stuff over again. So I see a lot of progression, and citizen science can help us with that.
Yeah, exactly, and it's one of those ways. If you can harness it in the right way, you could really get a lot of this stuff done in really creative ways. So, guys, I want to thank all of you for your patience on this one. I can't apologize enough for I don't know what happened, don't know why it died, but it did, and we started again. You guys followed us here. Thank you very much for doing that. I wanted to let you guys know that we have another hangout on Friday where we're going to discuss the 30-year astrophysics roadmap for NASA, and we're going to have the people who are on the committee to discuss some of the plans that NASA has for astrophysics in the next 30 years. And my big question is, how does NASA know what it's going to do that far ahead? So I'll hope to have an answer for you on that. I want to thank all of the guys for the M83 Stardate project, Stephanie, Carol, Brad, and Bill Blair. We have some of the actual people who worked on it, some of the citizen, the larger contributors. One of them actually emailed me back to say they never got the email. So, in addition to Google technology not seeming to work, apparently my email is not getting through to people either. So, I'm really sorry that they couldn't join us. But we want to thank everybody for their participation into the project. I really think that all the work that's going to come out of this will be really interesting, and we will keep you posted on the papers as they come out. Thank you all for watching, and as always, keep looking up. But it is no longer they're no longer taking the data that are coming off of it, and now they're everybody's just sifting through the results. So Brad Whitmore, you are one of the leads astronomers that was working on this issue. You're an astronomer at Space Telescope Science Institute. Tell us a little bit about what you've learned from this whole experience. What were some of the surprises that you found from the initiative?
I think the biggest surprise is that these citizen scientists are really good. I thought.
Oh, that's no surprise. Come on.
I thought that they'd be kind of overwhelmed by some of the complexity and stuff, and they just, like troopers just kind of got in there, asked a few questions, and away they went. I'm going to just real quickly show some results. And
here's Stephanie. Great, we're back where we started. So everybody, my name is Tony Darnell, and I'm the social media manager for Space Telescope Science Institute, and we have been at the mercy of a lot of technical difficulties today, but we want to give you an update on a citizen science project that we have been working on starting in early January, which was called Stardate M83. It was a project that was designed for the Zooniverse Citizen Science Initiative. They have a whole family of these things, and this was one of them. And it was designed by all of the people that we have here with me. I won't spend a whole lot of time in introductions. We'll just talk about who they are as we go. Hopefully. Okay, hi everybody. We're back. Sorry about that delay. It was or that dying event. It was. Apparently the event just ended, and we couldn't get it started again, so I had to create a whole new one. I put it in the link to this event in the old event, so hopefully you guys are migrating over as we do this. This is twice this technology has sort of messed up on me, so hopefully that won't happen again, because we've got another one coming up on Friday. So we don't have we run out of a lot of time. I don't think anything we said before got posted. I think it's been dead from the very.
To show that the basic
let's
idea.
Jump right to the punchline. Let's go ahead.
Yeah. Okay. So let me screen share here.
Yep.
There we go. Okay. Now let's see, which of these do I hit? I guess let me try that one.
It's the red. It's the little green button.
The little green button. Yeah, that green button.
There you go.
Okay. How's that?
Got it. We see.
Okay. So there is M83 the galaxy. And these are examples of some star clusters. And the whole idea is whether the citizen scientists can measure the ages. And so to test whether that was happening, I'm going to go to a discuss feature. Now this was the fun thing about it, that besides just using the tool, once people had met. You
guys can still interact with us via the event page and Twitter and using the Hubble Hangouts tag and everything else. So, Brad, why don't you the M83 Citizen Science Initiative is kind of wound down, and we're going to go ahead and assume that people have seen the previous Hangout. If you haven't seen the Hangout on what this is about, to kind of give you an introduction into what this is we're talking about, I would encourage you to watch our last Hangout topic, which is on our YouTube channel and on Google+. That'll give you some background. Today, what we'd like to talk about, though, is how it went. The website is still up.